Do not watch this video unless you've already practiced the first question on page 12. For this question, they give you a circuit. You know that this is a parallel circuit because of the number of paths that you're able to take around your circuit. So in this case, you have 3 paths, 3 resistors, 1 resistor on each path. Okay. We want to calculate all of the unknown quantities using our chart. So that's what we're going to do first. In parallel circuits, we know, if you look on page 4 of your parallel circuit rules in your reference table, we know that in a parallel circuit, all of our voltages are constant. So because of that, I can go through and I can add 10 volts to all of, for each of my resistors, R1, R2, and R3. They also give us the different resistors in the circuit diagram. So we can go ahead and we can label those accordingly. So we tell us that R1 is 10 ohms, R2 is 20 ohms, and R3 is 50 ohms. Okay. The next thing that we want to do is solve for your total resistance, or Req. The formula for that, 1 over Req is equal to 1 over R1 plus 1 over R2 plus 1 over R3. If you substitute in, you end up with 1 over 10 plus 1 over 20 plus 1 over 50. When you put this in your calculator, make sure you use parentheses around each term. And when you put this in your calculator, let's see, 1 divided by 10 plus 1 divided by 20. Again, make sure you're using your parentheses there. And you should end up with, as a decimal, as a decimal, is 0.17. However, this is equal to 1 over Req, and we need to make sure we're solving for Req. In order to do that, we're going to take the inverse of this. You can again raise it to the negative 1 power. You can do 1 divided by your answer. Either way, it is totally up to you. If I raise this to the negative 1 power to make sure that we're taking our inverse, this does not mean that you are just doing 1 over this number and then it becomes 17. That's not the way it works. You actually have to do the math. And if you did your math correctly, you should have ended up with 5.88 ohms as your total resistance. 5.88 ohms as Req. At this point, you can go ahead and use V equals IR to solve for all of the unknown quantities. So V equals IR, we're going to save some time here and just put in our answers. 1 amp, 0.5 amps, 0.2 amps, and my total should be 1.7 amperes. Solving for power, again, you can use any of the formulas that we have, V squared over R, or you could have done I squared times R as well. Whichever way you chose to do it, you should have ended up with 10 watts for R1, 5 watts for R2, 2 watts for R3, and 17 watts as your total power. If they asked you how much power is produced through the 20 ohm resistor, well, then you look at 20 ohms, you go over to your power, and that's your 5 watts. So you just have to make sure you're labeling everything correctly. Letter B says to add an ammeter to your circuit. It doesn't specify where you want your ammeter to go. So I'm going to put my ammeter right over here. Here's my A. This current, just to go through this for a second, this ammeter where I placed it has the ability to now travel down each path where your resistors are. So where I place the ammeter, it would read your total current in your circuit. If you chose to place the ammeter, say right here, well then this current is only going to read through R2 because it's only on the line with R2. So wherever you place your ammeter, if they told you where they actually wanted it in terms of how much current that should be read, that's important where you place it. For part C, add a voltmeter to your circuit that would read the voltage across R1. So we want to make sure we're putting this voltmeter so that it is associated with R1. So I'm going to, that was kind of small. I'm going to put my voltmeter right here. And we have to make sure that we take wires and connect it so that it is across only R1. Here's R1. So you have to make sure that when you do this, you're making it solely go so that it is around only R1.